Yeah, I know it's the last session, so probably not many people to wait on, but yeah, okay, perfect. Um, so yeah, yate everybody. She'e Nicholas Rajan Yinishe, Kiani Nishli, Ado India Bashichin, Ado Oneida Iroquois Turtle Clan Dashache, Ado India Dashanelis. Um, yeah, I'm a natural resources specialist with the Intertribal Agriculture Council, and I'm presenting along with my co-presenter here, Javis Davis, and some help from his colleague Sean Parker, all about ecosystem functions, as well as my portion of the presentations focusing on soil quality, soil health, as well as its interrelationship with water quality. I'm not sure if you want to come up now, Javis, or as we go through, because we kind of split out our presentations. But yeah, yeah, cool.
Good afternoon, everyone. Hello, my name is Javis Davis with the White Mountain Apache Tribe. I'm the tribal hydrologist.
Yeah, okay, nice. So yeah, one of the most important things that when we talk about ecosystem function in our natural resources is all about protecting our natural resources, and water being chief among them. We want to protect our water quality for many different reasons, and obvious among them is for safe drinking water for ourselves, safe drinking water for our communities, but it's also important for protection of fish and other organisms within the environment, and also the water that we have on our tribal lands, within our landscapes, that feeds the plants that end up feeding ourselves, but also feeds our livestock and the animals that we depend on as well. The water is also very important for our culturally important species and medicines, and also prevention of pollution and uptake is much easier to handle, much cheaper than cleaning up that pollution. This figure is just showing groundwater pollution of nitrates throughout the USA, and especially in shallow groundwater. And you can see that the heightening levels of nitrates is a growing problem. And while it may be remedied in some areas, you can just imagine with increasing inputs, especially of fertilizers into our systems, that it is very crucial to keep in check. One very important thing is that we've been managing for water quality, water quantity for millennia. These ways of water conveyance and also water purification have been used and can still be used out into the future. I just wanted to mention, I usually do that the Maya actually developed incredible water filtration methods some 2,000 years ago. They would incorporate utilizing volcanic material, zeolite, along with quartz, and intermix these materials in between woven grass mats and their waterway systems and their conveyance systems in order to filter out heavy metals, other pollution, and they were actually drinking the cleanest water from a purification standpoint in the world. Nowadays, like LA municipal water districts, Phoenix municipal water districts, modern water filtration systems use the same type of materials, volcanic materials, charcoal, and like these quartz materials in order to filter the drinking water that we have today too. Very important as well are clay filtration systems from the Southwest. These have been utilized for thousands of years, and also today in order to filter out heavy metals and things like arsenic, lead, and they're actually being used as well for uranium uptake, heavy metal and radioactive metal uptake and filtration as well. So this is traditional knowledge, it's indigenous science, and can be utilized for today. Very important demonstration of this comes through Paiute Numu agriculture in comparison to Western forms of agriculture. When we think about the way that Paiute utilize water systems, it is very much incorporating not only their needs for water, our needs for water, but also distributing that water through the environment to help the entire landscape and ecosystem. The agricultural fields of the Numu are enhanced to fit the plants that are in the area, and it also increases the quality in the endemic plant habitat. And these are sustainable systems. The way that we've been able to study them, they're at least 400 years old, if not for sure thousands of years old. You compare that with Western agriculture, in which ditches and water is transported, they're terminal. So we're going to take water from one location and make sure that it reaches like Los Angeles without thinking of all the environment, all the spaces, people, and creatures in between that. The fields in Western agriculture, they're constructed to fit the machinery rather than the species that are native to that area, especially the good quality foods that are in the area. And on top of that, the crops that are grown are imported crops, and these imported crops require imported nutrients and imported inputs in order to sustain them. So while they're profitable in the short term, they're not looking out for the natural resources. And as we begin to lose topsoil, they'll no longer be sustainable at some point, and that point may be reaching us sooner than we'd like. So to begin, especially for tribes and for our communities throughout Region 9 EPA, we want to first of all protect our water quantity. We live in very arid landscapes, and water is very precious for all of us. So we want to protect how much water we have. Whenever there's heavy rain events, we want to make sure that it's not just running off, going into the ocean, leaving our lands. We want to make sure that it infiltrates our shallow groundwater and then stays there so that it can recharge our aquifers. So to do that, we want to first think about slowing down that water cycle rather than having direct just terminal ditches that transport water as quickly as you can from place to place. You want to slow down the water the way that nature naturally has it, meandering streams and things of that nature. We want to utilize regenerative practices as well in order to increase water holding capacity of our soils. And also by improving our riparian habitat, our natural habitat, we can also help to slow the water cycle and also increase our water quantity. We also want to improve water storage to collect during times of more precipitation. And an example of encouraging and working with nature, we want to encourage beavers in natural waterways where they're native, especially because the beavers, they're raising the water table in the environment and downstream of where they're constructing their dams. And yeah, overall, we want to reduce runoff, reduce erosion, and protect the pool and riffle formations in our waterways as well. Now, as we transition into talking about preserving and protecting water quality, it's important to note that there's a direct correlation and connection between water quantity and water quality. You can imagine taking a teaspoon of gasoline or like pesticides and adding it to this bottle of water, and you wouldn't want to drink that. But you imagine now a swimming pool, and you're adding that same teaspoon into that swimming pool, and it's going to be a little bit safer to drink. You'd rather drink, if you were forced to drink a cup of water, you'd rather drink from that swimming pool. But that's the direct correlation there. However, when we're getting big rain events, when we're getting flood events, even though we're getting increased water quantity into our lands and into our water systems, and introduction of new pollutants and chemicals that shouldn't already be there are now introduced. So there are negative impacts that come from higher flows, and these negative impacts from these new pollutants that shouldn't be there can be reduced by building soil and reducing sources of pollution. Now, in order to protect our water quality, what can we do? Well, one of the principles is slowing down that water cycle. When you have quick moving, fast moving water, channels that have been dug just to distribute water as quickly from one place to another, that fast moving water will carry sediment with it. It will also carry pollutants, pesticides, fertilizers, increased nutrients as well into our water systems. And less of that's going to soak into the aquifer and also naturally filter out too. Other ways to protect our water quality is to limit the inputs that we're putting into the soil and putting into the water as well. This also includes organic fertilizers, and we also want to be careful on placement of septic systems, and also including barriers to prevent runoff around manure piles helps with this. Excess nutrients getting into drinking water increases nitrification and risks of things like blue baby syndrome, terrible condition where especially when you see it in babies, their nitrates in their system start to build up so much so that they're no longer able to process oxygen and they actually suffocate. And while it affects babies in this terrible way, it's happening to us too if we're consuming water with excess nitrates. So we want to limit and eradicate that, really. And excess nutrients in general also cause eutrophication and result in fish kills and dead zones in our lakes and in the ocean as well. The nitrification of drinking water is increasing and is definitely even more so at risk around the country. And as you can kind of see in these agricultural zones where there's lots of industrial agriculture taking place, lots of pesticides, lots of chemical inputs, and especially fertilizers. So we want to get rid of this vulnerability, and we want to reduce our nitrogen inputs that aren't natural to the environment as best as we can in order to protect our communities. And globally, all this nitrates, excess inputs, they flow off into the ocean, and it's resulting in ocean dead zones all around the world. So this is really a global issue that needs to be confronted. So when it comes to protecting our waterways, ways to do this is to keep our soil covered in order to eliminate runoff and erosion. There's many different ways to cover soil. This can come down to like cover crops and living cover, native vegetation, all the way to like mulches and even like soil armoring. We also want to protect riparian corridors. Having buffer improves habitat, especially for pollinators and birds and other key species, while also preventing erosion and sedimentation. And it also lowers water temperatures in our waterways and increases dissolved oxygen content and also parameters that are needed for most fish and aquatic life to thrive and also to live unstressed. Allowing for space for habitat protection and encouraging species diversity allows us to maintain ecosystem function and helps to protect water quality as well. And you can always get in touch with us at the Intertribal Ag Council and the Natural Resources Program if you have any questions on how to improve or restore your water quality and riparian habitat. And all these things interact in an agricultural sense, especially when we start to consider agroforestry of our forests, deserts, and grasslands. So ways to slow the water cycle and prevent non-point source pollution, keeping the soil covered. Raindrops alone impact soil so much. They just have a high velocity when they strike the ground and they displace soil particles. And also you can imagine pollutants that are in the soil as well, causing them to run off into streams and causing sedimentation and increased pollution. So any kind of soil cover will help to break up the force of that raindrop. The best soil cover that you can imagine is going to be living cover. Continuous living cover with good soil structure and microbial life is the best long-term solution in most instances. The soil is very much like a sponge and will absorb more water, keeping it where we need it and also refilling our aquifers. Armoring is not necessarily ideal, just like putting in stones or cobble into our streams for that kind of protection. But in some cases in which unnatural impacts and causes have created severe erosion in the water channel, it's sometimes necessary to have some armoring in order to slow the flow, especially on the bank, allowing it to then revegetate. Avoiding soil compaction is very important here as well, and also avoiding impervious surfaces. And swales as well can be used in strategic areas to help slow down the water cycle. Keeping that soil cover. I'm in a room with a lot of environmental experts, so I don't need to dwell on this too much, but there is a difference between point source and non-point source pollution. Point source pollution, you can imagine like a factory or somewhere where there's like an obviously identifiable source of pollutants entering into an ecosystem, and non-point source pollution would be something like the runoff coming from a rain event entering into like water systems, streams, or into our environment from a non-point source. So in general, we want to consider the connection that exists between soil health and our water quality. Water quality can't be considered without looking at soil health because soil is the filter over and through which water runs. And every pollutant that ends up in the soil can be expected to enter into either groundwater or surface water as well. Healthy soils, in contrast, healthy soils will reduce pollutants and also help to protect the water. Also, pollutants that destroy or impact soil health negatively, they also impact water quality as well. So protecting one helps to protect the other one. And soil health loss can be an early indicator that you'll soon be losing water quality, and working to improve that soil health before it degrades further can help protect water quality of our water sources. And whole ecosystem function is important to keep that in mind. So the principles that we always share with producers, with tribes, is to manage for soil health and water quality. You want to minimize your soil disturbance. You want to be low till, no till. You don't want to just be ripping up that soil, all the microbes, microorganisms, and habitat that exists in the soil. You want to keep the soil covered. And biodiversity is very crucial. So you want to be growing lots of different plants, and you want to be rotating your crops as well. And doing our best to keep living roots in the ground year round will very much help for helping build soil health. In addition to keeping the soil covered and minimizing that soil disturbance, integrating animal use is incredible for building up soil health, especially, and it needs to be noted that the animals need to be managed regeneratively, with giving adequate recovery periods to the vegetation that's in your farm, in your area, in the landscape. By doing this, we can maintain stable aggregates in our soil, reduce erosion and runoff risks, buffer temperatures in the soil and also our waterways, reduce evaporation of water, and this all helps to maintain and also build our soil organic matter. Building that soil organic matter is very crucial for water holding capacity, infiltration and storage, as well as nutrient holding capacity in our soils. Improves habitat and biodiversity. And also, when we consider agriculture, it prevents the loss of important amino acids like ergothioneine. That's something that's produced by fungi, and it's lost with tillage because when you till, the sun rays just cause that to break down, and we lose that crucial nutrient. So rather than feeding just like plants, rather than feeding like our crops, we want to be feeding our soil biology. And we do that by keeping living roots in the ground all year round, because as plants are photosynthesizing, they're releasing root exudates into the system to feed those microbes, those archaea, bacteria, fungi. And also by growing different plants and rotating our crops, we also help to feed that soil biology. By having healthy soil biology, microbial communities around our plant roots, you break disease and pest cycles, you stimulate changes below ground for biodiversity, and you also increase soil organic matter, increase nutrient cycling, and overall you're enhancing plant growth while also increasing predator and pollinator populations, which are helpful for all environments, whether it's the farm or out in the forest. Healthy soils have a huge number of benefits for the planet. Healthy soils are drought resistant. They're stable and resist upon erosion. They also store a lot of carbon, and healthy soils will resist pests, pathogens, and disease. And during stressful events like droughts, even earthquakes, fire, healthy soils help plants grow and survive through these stressful events. This is in contrast to collapsed soils. Collapsed, unhealthy soils encourage pests, pathogens, and disease. They restrict water infiltration, and they're also very much deficient in nutrients, and they need chemical fertilization, and they do not buffer temperatures in and on the soil around riparian areas when we consider these collapsed soils as well. And in those stressful events, they increase plant death, and they just don't impact the health of the environment, plants, animals, human life as well, and nutrition in the same way as healthy soils. So tying this all together, we have to consider whole ecosystem function, because the value of the ecosystem function is worth more than the sum of its parts. We can't look at water, soil, air, habitat, microbiomes of the creatures and ourselves separately as if they don't impact one another. Nature works with these cycles in systems that are all interconnected, and an imbalance in one system will lead to an imbalance in another. Indicator species are the first signatures that an imbalance is occurring and should be monitored for. And especially keystone species, they'll create food chain collapse when disrupted, and the loss of keystone species generally comes after ignoring signs from indicator species. Everything that happens in an ecosystem impacts other things in that system. So there are some basic water quality parameters that we can all be looking for, monitoring whether it's coming from irrigation water, from our streams, from our lakes, from all these water systems. And these are basic things like temperature, dissolved oxygen, pH, conductivity, and turbidity. We want to be monitoring for temperature, and we can do that very easily with thermometers, infrared thermometers, in order to see just how cool our water systems are. And also, it's a good indicator to know if you have enough shaded areas in the stream and if there's adequate flow. Cooler water usually indicates a heavier flow. And we want those good, cool buffered temperatures as a hospitable environment for aquatic organisms. And if those temperatures get too high, you also end up losing dissolved oxygen content. Dissolved oxygen is another parameter that we can measure and test for with equipment and or like as environmental natural resource departments. Fish breathe oxygen through their gills, and they require that oxygen level to be adequate. Different species and different life stages of these species and aquatic organisms need different levels. So this really comes down to knowing your waterways. It's going to be different throughout many different environments. And if sedimentation ends up filling in the pool and riffle formations as well, and or there's high water temperatures, the dissolved oxygen levels drop. The tumbling action of water over riffles and pools is what can help reincorporate oxygen into an environment. Just how acidic and basic your water systems are is important to track. Generally, distilled water is going to be 7, so you can expect to see a variation of this between anywhere from a pH level of 6 to about like 7.88. It really depends on the geomorphology, geology of the environment that you're around, as well as what plant and what kind of animal species are in that environment too. But if you see something that's very acidic or something that's very basic, that's a good sign that that something is wrong, and there's a good sign that there's pollution somewhere in your water system, and it's no longer hospitable for aquatic flora and fauna. The parameter of conductivity is another one that we can measure relatively easy. This is measuring the electrical potential of water. Again, distilled water is going to have a conductivity of 0. So in our natural streams and systems, you can expect to have some potential, but really elevated levels of conductivity is commonly seen with salinity and pollution as well. And this final kind of basic water quality parameter that we can think of is turbidity. This is the amount of sediment that's suspended in the water in an environment. And when your water is highly turbid, this is usually a sign indicator of active erosion, and this can cause severe issues for wildlife, stream health, and water intakes. I'm just considering the impacts to like breathing for fish, or like spawning, fish spawn, when fish need like gravels in their stream banks rather than fine sediment, which doesn't allow them to go through their life cycles. A very important way of understanding measuring your water quality is actually through biodiversity. Understanding benthic macroinvertebrates are crucial to testing and monitoring your water health. Benthic macroinvertebrates are commonly used to determine water quality because these are small invertebrates, small animals and larvae. And when they're collected in a laboratory, that laboratory can give you an index of what these species are like. And when you find a high number of species like bloodworms, true flies, other species that are highly tolerant to pollutants, and you find a lack of other species or you find a lack of biodiversity, that's a clear sign that there's some issues with your water quality and that your water quality is suffering. When you do that index of your species, you can also you're also given an EPT index. This EPT stands for the Latin names of mayflies, stoneflies, and caddisfishes, that being Ephemeroptera, Plectroptera, and Trichoptera. You can tell I'm not a biologist, but these are very sensitive species for an example. And they'll range between different aquatic systems. But if you find a lack of these species, or if you find good biodiversity and a good spread of these species, that gives you a clear indicator of your water quality and your stream health. So yeah, the more biodiversity you have and the more of these sensitive species you have, the better. Overall, there's many different ways to monitor for water quality, and I think that when we're speaking with when we're hearing from Javis and the work that they've done at White Mountain Apache, you can get a very clear sense of methods that they've used to monitor water quality. So I'll definitely leave that for them. But please look at this if it's very interesting to you in the Excel events, and these are just really good parameters to take a look at. So I'll be transitioning on over. I did include in my presentation just some information and some examples of indigenous water management. This is of the Paiute Numu irrigation, which is just highly incredible, the methods that were used to find that out. And if you want, I have a very long lecture about Lake Cahuilla and the Colorado River. So at any point, feel free talk to me after after the presentation or send an email. And this is just an example of that Mayan water filtration system that they found that they created 2,000 years ago. So I'll end by saying that water is life, water has a memory, and these are some really good resources to look at water quality. And I'd like to pass it on over to Javis and Sean Parker. Thank you. Yeah.
Thank you. So my name is Sean Parker. I am from the White Mountain Apache Tribe. And I'm just going to do a few slides for Javis real quick. I do the 106 and 319, the water quality on our reservation, and Javis is our hydrologist. He's been here longer than I have. I've been here 2 years, and it's been a pleasure being here with you guys and introducing and kind of giving some background, which I feel is important. As I'm understanding, we all come from different places and different just different backgrounds, and as natives, I think it's really important. So we are Nde, or to us the people, but to everybody else they call us White Mountain Apache or Apache or the enemy. For us, we call ourselves Nde. We are located in eastern Arizona. We have approximately 1.67 million acres. Our elevation ranges from 2,600 feet to 11,400 feet. So it ranges from cacti all the way to above the tree line. We have our own ski resort, and we're mostly in pine, juniper areas. We have approximately 17,000 tribal members that are, last remember, living on the res. We have 15,500. Zifli Gaisian, that's White Mountain Apache, that's White Mountain. It's Malt Baldy, the Malt Baldy mountain range. It's a sacred area, not just to the Apaches, but to the Hopis and the Zunis, different pueblos around the area. So we have 2,790 acres of lakes and reservoirs, 12,112 acres of wetlands, around 500 springs. Our water habitat ranges from marginal to high quality cold water. So the Phoenix metropolitan area receives 72% of its water supply the surface water from the Salt and Verde rivers. Our primary recharges the groundwater to the groundwater is from snowpack, which is, it kind of has been varying. Last year was really good snowpack, so we saw quite a bit of runoff. We received our TAS, treatment as state status, in 1997, and our approved water quality standards from the EPA in 2001. So we're a mature program. Some challenges the White Mountain Apache Tribe has would be uncharacteristic large wildfires. I think we had the Rodeo Chetasky, which was now second or third largest fire in United States history. Livestock, we've got quite a bit of livestock that's managed and unmanaged type livestock, horses and cattle. Persistent drought, declining snowpack, water quality and quantity and quality impacts, and historical mismanagement done by the tribe and not by the tribe. So the roads and bad logging practices, not following tribal BMPs, in-stream gravel mining, invasive plants and trees, etc. Okay, I'm going to hand it off now. Just that was a quick background of where we come from. I'm going to hand it over to Javis as our hydrologist.
Thank you, Sean. So going to be transitioning from kind of what Nicholas spoke about to actually implementation on the ground work that we kind of that our program did. So we have abundance of streamflow data, mostly resulting from getting ready for our water rights. We have a lot of we have about 13 streamflow gauging stations. Half belong to the USGS, the other half belonging to the tribe. Some precip stations tied to BOR sites that monitor lakes and reservoirs, and we also have some NOAA sites and some snowtail sites on our reservation. We monitor temperature resulting from our 106 funding, and we got a variety of geomorphology tied to restoration practices dating back to like the early 1990s, and we're just kind of collecting data as we go. We have a lot of we have some riparian and wetland data. Of course, we're always monitoring our snowpack, see how much runoff we get during the winter, and kind of keeping downstream stakeholders, kind of keeping them in the loop. Just in the last decade, we started monitoring macroinvertebrates, and kind of really started implementing that into our program. And just the last 2 decades, we're kind of finally getting back into it now, is monitoring fish tissue sampling, and also now incorporating TEK into our program monitoring. So a lot of data, right? Where do I start? We have a lot of data sources. Oh, I'm supposed to change that, aren't I? Uh-oh. I apologize. All right, so here. Okay, I got it. All right, so we have a lot of data sources, and kind of get overwhelmed. It's easy to get overwhelmed when you have how do you use this data? It's easy to get too close to data, and it's easy to get too close to your data and not see the big picture. So that was our issue when we first started getting our program back up and running again, and also coordinating with different departments, forestry, game and fish. It's really a complicated effort because we had a lot of turnover. So just kind of reestablishing the coordination between our programs, and kind of just trying to find a methodology that really kind of utilize our data with trying to incorporate a interdisciplinary method to analyze our data to help supplement our assessments here. So, whoop. Oh, okay. All right. So, roughly about a decade ago, we started doing, like I said, we started macroinvertebrate assessments. We contracted Dan Mosley and Bob Hall kind of helped us, and they point out something that really kind of stuck out is that they kind of noted that we had to stand back and take a look at the way we're evaluating our watershed, because we're getting stuck in concentrating water quality, biological surveys. We really need to step back and look at the watershed as a whole. So, with that in mind, they introduced a concept of PFC surveys, proper functioning conditions. And, okay, so, all right, so, 15 minutes, okay. All right, so one big issue here is that, what was pointed out was that water quality biological monitoring is a lagging indicator. So we needed to find some way to better assess our watersheds, and that's part of the reason why we really wanted to start doing PFC, proper functioning conditions, because it gave us the opportunity to qualitatively assess our watersheds using our data. So, am I here? Okay. So, a good thing about PFCs is that one thing that really taught us was that it really defined issues that really need to be addressed. In our case, our big issues is livestock and secondary roads. It really kind of pointed out that we really need to coordinate with our livestock managers, because that's the main reason why our higher up watersheds were degrading. And also, we need to coordinate a lot better with our tribal transportation department and the BIA to manage roads, because it's causing a lot of erosion and a lot of sedimentation in our streams. And also help us point out the appropriate monitoring. It pointed out that we are lacking wetland, riparian vegetation assessments. So now we're actively implementing that in our program. Also, finding out what's appropriate. Also finding appropriate management practices. Really implementing BMPs, again, coordinating with different agencies to make sure these secondary roads are managed, because it was really impacting our watersheds, especially high up. And also kind of really better defined how to better assess our watersheds. Kind of grouping it by kind of grouping and almost like a triage, kind of which areas we should concentrate in. And the good thing about this is that PFCs is universal. So in the event if I end up leaving from the department or retiring, somebody else can come and write it and step in and start continuing our work and using data to continue these assessments. All right, so next, so let's zoom in a little bit. So this is Lofer Cienega. It's going to be our case study for our actual on-the-ground implementation of PFCs. So Lofer Cienega is located on the eastern part of a reservation near the southern flanks of Mount Baldy. Elevation ranging from 7,800 to 8,000 feet. Soil types, silt loam, alluvium derived from volcanic rock. The type of wetlands that we have there, it's like a pedestrian emergent type wetlands, that wetland meadow, that Cienega kind of popping up there. And also different type of wetlands, so our streams. And one thing that's kind of notable about this is the first order stream. So not too far up the watershed, that's where the water daylights has surface water. And our co-op identifies this reach as a high quality cold water habitat. Next, all right, so we got another map here of what's an Apache trout. So this Lofer Cienega and the surrounding watershed is habitat for natural reproducing Apache trout, which is a keystone species, and presently is listed as a threatened. Presently is identified as a threatened species. So trout require to thrive. They require cold, clean water, and their spawning habitat needs to consist of gravel and free of fine sediment. So when you kind of consider, you have livestock kind of frequent area on roads, it could really impact their habitat. And the big concern we have was in this particular reach was that this area is a desirable forage area for cattle and elk, and the White Mountain, that area in particular is really our tribe is known for hunting for elk. So people coming from across the nation to come hunt on our reservation. All right, so next slide. Right, so here I got a slide. I know I apologize, it's hard to see, but we actually received funding from the EPA to do a restoration project. And progressing from left to right is you're going to hear me mention a couple of times that we had a really good monsoon in 2022 last summer. That kind of it persisted and followed right by a really good snowpack. So luckily, when we implemented our restoration project, right before it started, it was really dry, and as soon as the project got implemented, the monsoon started up, and right away within a month and a half time span, we started seeing progress really quick. So that's something we learned is if you can time your restoration project if a monsoon or a really good runoff, you might see some more positive impacts at a faster time period. But the objectives for our project was to implement to construct some check dams and maintenance. Maintenance check dams already had in place. Construct a livestock exclusion area, and this was to prove to the livestock managers that kind of letting that meadow rest, that forage area that they really like to use. If you give it 2 or 3 years of resting, that would provide a lot more suitable forage area for cattle and wildlife than to just really beat it up every year and not be as productive. And that's what would benefit us because benefit our resources because there'd be less erosion, and it'd be more resilient. And another aspect of this project was to again collect water quality data, follow up with another macroinvertebrate survey, collect geomorphology data, perform another PFC survey, roughly almost 10-year lag, and just to see how our progress is doing with how our conservation were. Whatever now are we doing a good job, bad job, just to give us a kind of report card, and to monitor vegetation. So next slide. Another big, so in this watershed in particular, we had a big issue of channel incision and widening, and it was really hard to see. But there's a cross section kind of depicting the channel geometry, and you take a really good, you really examine it, and the channel is kind of incised, widened, and the water table dropped, and it got disconnected from its floodplain. So we also have like a nick point migration kind of migrate up channel, and we lost in that area in particular lost a lot of wetland riparian areas, and also followed by loss of channel sinuosity. And we saw this popped as a lagging indicator. Of course, temperature increase, water temperature increase, turbidity increase, and for this particular reach, what was surprising was, the upstream of our project area had macroinvertebrate that trout really love to feed on. Damselflies, mayflies, and downstream, maybe about 100 yards or so, you start seeing leeches, bloodworms, flies. So just really change in water. Just to change the water quality really quick, and that really indicated that we really need to. That's what really kind of pointed to where we really need to change management of this area. Right, next, so everybody here in the office are from the Southwest. Oh, wrong. Thank you, Sean. All right, so another big thing is drought, right? I've never seen this happen since I worked here. I know about, but our creek dried up twice consecutively. Bad snowpacks followed by poor monsoons. So when this happens, we're kind of finding out that it's really hard to coordinate. The livestock managers are less likely to coordinate with you if there's not that much water available, and all the forage areas are near your restoration site. So they're going to want to get their cattle into an area that you're actively conserving. So that's one issue we kind of ran into. But like I said, we're trying to coordinate with them to trying some methodology to prevent them from actively using our conservation areas. Also, when water supply is low, other wildlife start to frequent your restoration area. So it's kind of complicating conservation efforts. All right, next. All right, so roles for data results. I kind of mentioned earlier that our McIntyre survey kind of indicated a sharp transition from good to good water quality to pollution tolerant to an area downstream that was more polluted, had more McIntyre that are tolerant to pollution. We also noticed that the water temperature was increasing further downstream. And right now it's too soon. I mean, it seems obvious, but part of the reason why it could be loss of there's no tree cover in that particular ridge. Our photo points are indicating that we did see some expansion of wetland riparian area, and we're still kind of waiting to interpret how that'll turn out, whether it was just a seasonal thing or is it going to kind of persist. And a good thing about our PFC survey this last year was that it kind of reported that our particular project area is functional at risk with an upward trend compared to functional at risk of a negative trend. So that was when I heard that, was a little happy to hear. So one important thing that PFC result, our watershed assessment is kind of really pointing out, and really kind of help us narrow down more, is that the place needs more rest. 1 year wasn't enough. We probably need another 2 or 3 years to really get that area stable against erosion, and that the riparian wetland plants really need to they need an age diversity. We need an older wetland plants to stabilize those stream reaches against flood events. Also pointing out that we needed to stabilize head cutting, and I keep saying this, but improve our coordination with livestock managers, and consider expanding our conservation area, increasing surface area. Right, and also we also pointed out the need to implement a vegetation monitoring program. Like I said, we had a lot of data before, and this is something that it pointed out that we lacked. And when I first kind of started, I didn't really feel a need to implement for vegetation, but this survey kind of said otherwise, that we really need to get back in there and kind of look at it through a watershed, kind of zoom out and look at the watershed aspect, the whole watershed as a whole. And also now we're coordinating with hoping to get work with NRCS and our local livestock managers to implement a livestock rotation practice. And also our new objective is to connect our channel with the floodplain, and I don't see that happening for at least, if it can prove 25, 35 years, but let's see here. So another thing we found is, like I mentioned, timing. Our restoration efforts we saw a lot happen, compared to prior conservation efforts, just because we benefited by that monsoon season that came in, that monsoon season that came in, and also that we really need to let that area rest. And so I guess in conclusion, I'm trying to say, I'll sum all this up, and kind of what Nick is what worked for best for us was going back, standing back for a little bit far, standing back for our data and looking at watershed as a whole, and finding, just finding that PFC really worked for us, looking at the watershed as a whole. And we could have got all this data without coordinating with local professionals. We coordinated in the past with the U.S. Forest Service to help us get restoration projects in place. According to USGS to get stream flow data, precip data, the BIA to get precipitation near the lakes and reservoirs, even SRP kind of helping us kind of find blind spots in the upper areas of watershed where we really need to monitor snow and precip, and a lot of coordination with non-profit organizations for on the ground help. And during this process, there was a lot of data collection training, outreach opportunities, cooperation, co-ops, and what really kind of brought all this out was actually coordinating with a contractors to really kind of point out that we need to look at this as a watershed thing versus just kind of really concentrating on channel and streams. And here, here is our goal right here. So, this is Lofer Cienega. You see the photos taken historically. You got a guy fishing there for Apache trout. You see the channel connected to the floodplains. You see a lot of our parent plants and woody vegetation, typically found in wetlands. That's all I got. Any questions?
Oh, okay. Thank you for the great presentation. I was sitting here as you were going through it, and I was wondering, like, well, what are your parent plants that are over that waterway? Because and at some point, I think we'll be talking with IAC to assist us with this, but we have difficulties with getting state entities to understand that they need to do riparian management in a good way. So in some cases for us, there are some tribes that are working on the riparian areas and actually following the cycle of when you release water down into a creek to allow fish to come up. But that not all tribes are getting to do that. And even on the opposite side, so here you have somebody removing all of that vegetation because of cattle or whichever, and you're trying to put it back. And it's interesting to see that, and to see that picture where you can see that vegetation there, which is what helps stabilize your banks and provide shade and covering. We have a little bit of the opposite, where we have too much in some of our riparian areas, and we've had some fires come through, and I got to visit those, and during the drought time, there was running water in August in these creeks where they would have been dried up otherwise, because all of this other vegetation up on the hills was removed. The trees were still there, but there was still enough shade for that creek for it to have viable fish, and to provide water that was coming down into the river. So I just want to say it's an interesting to see the opposite side. I mean, I've worked out in the Intermountain area years ago, and that was the thing, is the farmers, the ranchers were removing the birch trees and stuff, the beech out there. And we'd be like, why are you doing that? And removing all the beavers, when actually those things stabilize and reduce your sediment. So thank you for coming and presenting.
No problem.
Thank you very much. I'd like to apologize in advance that I have to run out after my question. So sorry. I wanted to know, you mentioned Dan Mosley. Could you tell us the name of the consulting firm, and also what GIS training you all received?
Oh, for GIS training, we get it through the BIA. So we have 638 contract, and I believe that it's through the EPA. Recent one's through the EPA, but we got a lot of training from someone who retired from not retired, but transitioned from BIA to the tribe. So it's a lot of our training comes from in house. Yeah, Dan Mosley, Bob, you want to show you? Is it,
native something or
I don't know,
I don't know, Dan and I have been working together for 26 years, so I keep forgetting. We have our own company. I'm EPA retired.
I was going to say, I haven't seen you in a while.
Yeah. the way, the answer to your question about beaver and cows, there's a direct proportional relationship between beavers and cows. You get more beavers, you get more cows on the range because it provides for water. If you're interested in just bugs, Dan is the person, I'm sort of the hydrologist, geomorphologist with Dan doing the PFC. So we actually have trainings for this. And we will also do the assessments with you. We don't try to do the assessments for you. We want to do them with you because you have the information, the historical information that we actually need to do the assessments. So,
Total watershed approach is what I
yeah. I gotta go. Thank you, Mark. Okay, I guess I get the pass them all out. I have to take them home with me.
Nice presentation. I was curious, for the ranchers, are they tribal ranchers or non-tribal? And like, how does it work out? Is it because, like, is it free range? Is it on their assignments? Like, you know, how can you work together with the ranchers there?
It's we have like a livestock association. They're given like the designated area, and they kind of rotate them at them. I guess I don't know the rotation schedule, but yeah. So there's a livestock association, and they have like a president, and they're given some land, and it's up to them when to get the cow in and out. Yeah.
I think it's a wrap. We're done then. Yeah, and please go up to the ballroom for the closing ceremonies.